Good morning, dear children. We'll start a new chapter today, spectrum. And this is the last chapter of light. Now, before we come to the term spectrum, let us discuss about the dispersal of light. Now, we will discuss the three things today. One is the dispersion of light, then comes the spectrum, and the cause of dispersion. Now, Sir Isaac Newton, he did some experiment to find the nature of light. He performed an experiment, and he considered that the light which is given by the sun is a white light. It is a white light. And this white light are uniform and homogeneous in nature. Uniform means this white light have got only one color, okay, that is white, no any other color, that is uniform. And this white light used to, and he expected that the white light used to produce a white image on the screen. It was his thought. Okay, so, and he tried to investigate about the nature of light, and he said that the white light, the light which is given by the sun, okay, is considered to be as a white light. And he was very optimistic, okay, in that point, that always the white light will produce a white image, okay, and the white light is uniform and homogeneous. But what has happened one day, he tried to investigate the nature of that white light. So to find the nature, he took a prism, a glass prism, which I have shown you in the practical, in the last class. Prism, a triangular prism. Okay, and the angle of that prism is 60 degrees, which is equilateral prism. Okay, so he took a prism and keep it inside a room, and through a small aperture from the window, he make the light from the sun to enter inside his room. And that light, when it enters inside the room, it falls on the prism. And behind the prism, he kept a screen, a white screen he has kept. So, when that light from the window, from the small hole, from the small aperture, from the window, when it enters inside his room, his living room, and falls on that prism, the light, when it falls on the prism, they get sprayed out into constituent colors. Okay, so before he believed that the white image has to form. But when he came on the screen, the white image has to be formed on the screen. But when he kept a screen behind the prism, and when that light falls on the prism, and from the prism when that light went back to the screen, he found that the image which has been formed, the image is not white. Instead of forming a white image, there are different colors forming on the screen. And he totally discarded, he totally threw away that theory that the white light is homogeneous in nature, it is a uniform in nature. Okay, and it didn't come true. It didn't come true. Instead of forming a white image on the screen, there were the 7 different colors forming on the screen. So that 7 different colors which are forming on the screen is known as the spectrum, which we call it as a band of colors. The band of colors, when it falls, the band of colors given by the prism, okay, is called the spectrum. And when that light, when that white light from the sun, when it enters to the room and falls into the prism, that white light they get deviated. Okay, that means the white light they get deviated at different angles inside the prism. You can see the white light they are scattered, okay, inside the prism. This is the white light. This is the beam of white light coming from the sun, okay, and entering and passing through the or entering inside the prism, through the prism, and from the prism again it refracted back, okay, and this is the white screen, and on the white screen the 7 different colors are seen. Okay, and he said that now the white light from the sun is not homogeneous, it is not uniform. Okay, because the experiment which he did, the conclusion which he got in that experiment was finally it was untrue. It was the white image is not formed on the screen. Instead of forming a white image, okay, the 7 different colors are cast on the screen. So finally he discarded that theory and he followed that the white light has got the mixture of 7 different colors. Okay, the white light has got a mixture of 7 different colors. So from this point of view, he gave the definition. Let us come to the definition of a dispersion. Now this dispersion is the phenomena of splitting of white light into the 7 different colors. The phenomena of splitting of white light into the constituent colors. Constituent colors means the 7 different colors are passing through the prism. The phenomena of splitting of white light, this is the white light and this white light gets split, okay, into the constituent colors passing through the prism is known as dispersion of light. So dispersion of light means the splitting of white light into the constituent colors. Constituent colors means the 7 different colors when it passes through the prism is known as the dispersion. And the band of colors is known as the spectrum. And this band of colors, where you will see the band of colors on the screen. And this band of 7 different colors is known as the spectrum. Okay, now how do this dispersion occur? Okay, now cause a dispersion. Now that means the light, they are scattered. They are not, this white light, they are not traveling in the same direction. They are traveling in a different direction. Look at it. Now what is the cause? Means now the different, now since the white light has got 7 different colors, and these 7 different colors are having a different wavelength. The wavelength are different. So due to the different wavelength of different colors, okay, they will deviate at different angles. The deviations are different because the wavelength of the different colors are not same. 7 different colors are there. And these 7 different colors are having different wavelength, and due to the different wavelength, they will deviate at different angles. Okay, and the deviations will be maximum and minimum. So here I have written a minimum deviation. The deviation is less, minimum, and the lower side deviation is maximum. Okay, the deviation means the bending of light will be more. Okay, and you can see here in this figure, you can see that the deviation of violet is more. That means they are bending at the base of the prism. They are deviating more. Whereas the red light is not deviating. So that means the red light is having less deviation or minimum deviation. Okay, so what it can be said that the deviation, okay, if the deviation will be more, if the deviation will be, if the wavelength will be more, then the deviation will be less. If the wavelength will be less, then the deviation will be more. That means the deviation will increase with the decrease in the wavelength. The deviation will increase with the decrease in the wavelength. The deviation will decrease in the increase in the wavelength, and the deviation will decrease in the decrease of wavelength. Okay, so therefore what we can say is that now the violet light has got less wavelength, and the wavelength of violet light is 4000 angstrom. This ADV can be read as angstrom. A-N-G-S-T-R-O-M. Angstrom. Okay? So violet light is having 4000 angstrom and red light is having 8000 angstrom. So that means the wavelength of the red light is more. So more the wavelength, lesser will be the deviation. So when we consider this and this according to the rays of light goes on increasing, and the violet is having a very least wavelength. The wavelength of violet light is very less, very least. Okay, and starting from the violet, indigo, blue, green, yellow, orange, red, as you go on, as the light goes just above the violet, the wavelength goes on increasing. Okay, the wavelength goes on increasing, and finally the red light has got maximum wavelength. Okay, and when the wavelength is more, the deviation will be less. Okay, when the wavelength is less, then the deviation will be more. So therefore, we can say that the violet is deviating more compared to that of red light, because the wavelength of the violet light is very less. So lesser the wavelength, more will be the deviation. So this way, what will happen is that now the white light, when it falls on the prism, they will get dispersed into 7 different colors, and this dispersion of light depends upon the angle of depends upon the wavelength. Okay, depends upon the wavelength and the deviation which it produces. So this is about the dispersion of light and the spectrum. Thank you.